Hello everyone, and welcome to our webinar on building secure user experiences with passwordless authentication. This presentation is brought to you by DiUS. We're a technology consulting company based in Australia, and we believe in creating a positive impact through technology on our clients and their customers, on the way products are built and delivered in our industry, and also the communities in which we work and live. My name is Matt Kairys. I'm a senior consultant at DiUS, and I specialize in cloud architecture, DevOps, and app development practices. We'd really love for you to engage with us on our community Slack channel during and after this webinar. So please feel free to ask questions which we'll be answering live and also shortly after this presentation concludes as well. So what's wrong with passwords? Passwords are a staple of our lives. We use them on a day-to-day basis, accessing many different systems in our personal and work lives. However, they've shown time and again to be fraught with problems that have significant impact on customers and also our personal experiences. Let's have a look at some stats that really highlight some of the challenges we face with passwords. Yubico, who are a leading supplier of security keys, published an annual survey on the state of password and authentication security behaviors. In this year's survey, they found that 66% of IT security respondents admitted to sharing passwords with colleagues for account access in a frequent sort of manner. So I just want to point out these are security professionals, not just standard users or just IT professionals. These are people that specialize in security admitting that they engage in this bad practice. Let's look at a few more. Those same security professionals also admitted, or 60% of them admitted to having not used any sort of form of two-factor authentication for their personal accounts. And additionally, a third of those security professionals who had been experienced of a victim of an account takeover of some past, that didn't actually influence them to change their password behaviors to prevent that sort of behavior from happening again. A little bit alarming considering that in the same survey that people that didn't have a security background were actually more likely to change their behaviors if they were a victim of an account takeover in the past. So just on those stats alone just show that if security professionals are doing it wrong, what are the general users having trouble with as well? So after seeing those particular problems, we can easily digest that some of the key impacts that it faces today, the passwords are quite mountable. So let's go through some of them. One of the key problems is that they're really difficult to create and remember passwords across simply because we're using so many different systems. All these different systems often use pattern-based rules for things like, for example, being able to have a password that has lowercase, uppercase, symbols, numbers, all that sort of jazz. And when you have these rules being different across so many different areas, it gets really hard to actually create consistent passwords. And what usually happens is that these users get really frustrated. They always start trying to find shortcuts to overcome these sort of patterns. So what actually happens is users are more likely to kind of form bad habits by doing this. This is when you see users sharing passwords amongst each other because it's hard to remember. Or even worse, reusing passwords on a consistent basis across a whole bunch of different systems simply because they've worked out a password that usually satisfies all these pattern rules and such. This can also lead to recording passwords insecurely. And what I mean by that is writing, for example, post-it notes on a desk or even putting in a text file on a desktop or something. Definitely being stored in an unsecured manner to the point that someone could easily find those passwords and potentially compromise their accounts on whatever system they've been using. So as of late, for the last decade really, data breaches are becoming increasingly more and more common, and a lot of these systems tend to expose passwords. Some of these major players in the market, for example, Adobe and LinkedIn, when they were breached in years past, they were actually storing passwords in a very insecure format to the point that these passwords could easily be cracked. And then if you had been reusing those passwords for a whole range of different accounts on the internet, it'd be very easy to actually break into all of them if you've been using the same password. So there's a service called haveibeenpwned.com that if you actually put in your email address, it actually searches for a catalog of different data breaches that they have access to actually work out if any of your private confidential data has been leaked. So this is limited to, for example, passwords, customer data, like addresses and such. I want to just point out a great quote from a security researcher that I quite like, Bruce Schneer, that I really feel sums up why security is hard to get right. Complexity is the worst enemy of security, and our systems are getting more and more complex all the time. If we can potentially remove that complexity from authentication, we can really only strengthen the solution for our users and make it a much more safer environment. So this is where we head into looking at passwordless authentication. Let's have a look at what sort of benefits this could bring over traditional passwords and how we can actually use it on the web using a standard called WebAuthn. So why passwordless authentication? Passwordless authentication lets us create new credentials for a range of different devices that don't need to use passwords to authenticate into systems. So this can help streamline the user experience by helping prevent users the need to actually memorize any potential secret users in the system. This could also be used in conjunction with existing password systems as a mechanism for providing additional forms of multi-factor authentication. In WebAuthn, the standard also known as the Web Authentication API that was recently introduced provides us with the ability to easily bring this experience to the web and let our customers have this experience and have a much more safer experience using the web in general. So let's have a look at what WebAuthn is. WebAuthn is a new standard made by the Web Consortium that aims to improve web application security when accepting user credentials through the use of public key cryptography. What public key cryptography is basically using two different types of keys, one private and one public. The public keys are what's used to encrypt data, and the private keys are what you use to decrypt that data. This form of cryptography, also known as asymmetric encryption, is commonly used on the web and many other applications we use in our day-to-day lives. So how does it work in a WebAuthn context? We have three key components. The first component is the authenticator. This is the device that helps provide a secure credential and can be in the form of a security key, biometrics, for example, fingerprint or facial recognition, and also certain devices like your phone. These authenticators are used by clients, in this case looking at a web context, it could be a web browser, but also the user is part of this flow as well, because more often than not the user will need to actually do some sort of action to confirm that they are authenticating their identity. This transaction is relayed to a relying party. So this is potentially a web server that is running a web application that you're connected to, or it could be an identity provider that you're using for your organization or application. So there's two particular types of authenticators that can be used. The first one is a platform or internal authenticator. This is an authenticator that's integrated and bound to a specific device. The best example for this would be something like a fingerprint reader on a MacBook or iPhone. So the reason this is a platform-bound mechanism is that some of these credentials cannot be passed from device to the next device. For example, while your fingerprint is unique, it is also unique to each device you register it on. These devices store it in a secure enclave, which means that it's very hard to actually rip that fingerprint out of that device and put it into another system. All these devices can do is essentially store these fingerprints securely and tell you if that fingerprint that you're trying to authorize yourself with is valid or not. These particular types of authenticators don't need to use a particular transport protocol because it is often an internal API of the platform. So things like USB or Bluetooth wouldn't be needed for these particular authorizers. We've looked at the examples. So for cross-platform is the next type. So this is the type of authenticator that can be used on multiple different systems and providing the same sort of credential guarantee. So these are portable, and the best example of this is using something like a security key. And these security keys made by, for example, YubiKey, use a protocol for transferring called CTAP, or Client Authenticator Protocol, which helps enforce a secure device-to-device authentication channel using transport mediums such as Bluetooth, near-field communication NFC, or Universal Serial Bus USB. So let's look at some of the advantages that WebAuthn provides. It's an industry standard backed by the Web Consortium that we mentioned before. This means we've got a common API for web applications to use to actually integrate passwordless authentication into the workflow. This means also that the standard allows for different types of authentication, so that the way this can be extendable in the future. And it is designed to be secure from the word go. It's using private keys that are not exposed outside of the client that's being used in. And this leads to increased trust in user account management, simply because users don't necessarily need to sign up with a password. They could use an authentication mechanism that they use on a day-to-day basis, such as their fingerprint. This also has an added benefit of having a much more seamless user experience. Users will be able to onboard onto products faster by being able to register accounts quickly without having to worry about passwords. and also being able to access those systems quickly on a day-to-day basis. So now let's have a look at a few demos of looking at a platform and cross-platform authentication using the WebAuthn API. So let's look at a demo I showed last year at Web Directions Code. So this example is using a platform-based approach where we try to register a credential for a user and select the USB security key. With a security key, we then insert that into the system we're using and then touch it as a user interaction to show that we do want to authenticate. We then need to specify that we want to allow that application to use a security key so that way it can actually access credential. From then, we can then try to authenticate using credential and find that it has been saved successfully against the application. The next application we're going to use is a cross-platform type authenticator. Using the same username again, we're going to register a different credential, but this time using Touch ID on the MacBook. So this is a credential that's going to be unique for that particular laptop and not being able to be portable to any other platform as well. We authenticate using the same sort of process and find that works as well. This is the benefit of a unified API. I hope you enjoyed that demo of WebAuthn with the cross-platform and platform-based authenticators being used to create a passwordless experience and showcasing how the API can be used. Now let's have a bit more of a closer look at the registration and authentication workflows being used in that demo. Michelle Warrentona wrote a really great article on WebAuthn, in particular how it was used with Touch ID and Windows Hello on the web, and some of the basics of that actual API. In this example, she highlighted the registration and authentication workflows that are common to the platform. In the diagram shown in the slide above, we highlight that there's a client that wants to create an account with the service, in this case a relying party. The client would need to generate a key pair to be able to exchange a public key, which the service can then be used to authenticate a credential on the platform. This way, the relying party can always request the client to sign a challenge using the private key that they have for that credential and validate with the public key if that credential is a valid workflow or not. Now for the developers, this code is probably a little bit more interesting. This is some JavaScript code that's being used to actually create the credential using the WebAuthn API. So let's break it down bit by bit. The first few lines essentially highlight the algorithm that wants to be used for the particular encryption. In this case, ES256 is pretty standard and is using values from the CBOR sort of standard. The challenge from server is a sample string, essentially. You'd have a randomized generated string securely generated on the server, which would be then sent to the client to actually challenge against. Going through each bit of the public key sort of option in that JSON payload, we have a challenge, which is essentially a buffer of cryptography random bytes generated on the server, and this is really needed to prevent any replay attacks being made from potential malicious actors. We have a relying party object, which can essentially designate information about the application or service you're trying to connect to. By default, this is limited to the domain that you're connecting to the web address to, but you can actually override these values as well. You can pass information about the user that's being registered. In this case, we could use something like the email address, but also display name for the user. You do need to be somewhat considerate of what sort of public information you do put in this, because it could be considered private and confidential and could easily be leaked. We specify what the public key credentials parameters should be in order to actually be able to register it on the server. And we can also specify optionally if we want to select a specific type of authenticator. In this case, we can actually choose that we only want to use cross-platform authenticators. In this case, a service may only want to use service keys, security keys for their service. We can also specify a more optional timeout. So this way, if the user does not enter their credential in a particular time, you can have the application timeout and handle that error accordingly based on how you want to control the user experience. The attestation is also a method of checking the authenticity of the document, in this case, the actual credential, and seeing if it's authentic. There's a few modes that we can use here. There's direct, which is essentially asking for the authorizer specific information. So something like security key can give you much more direct information. Indirect is essentially asking for anonymized information about the credential. So you might be able to find if it's a security key in something, but not really sure what manufacturer the type is. And also you might just not really care and just want to make sure that credential is being used, and you can actually request no attestation to be provided. After we set out those credential options, we can then talk to the API, essentially ask to create those credentials, and it tries to process and facilitate those requirements that have been specified by the developer. If everything goes well, in this case, we've been able to successfully create a credential, we get a payload back. The payload has an identifier and a raw identifier, which is basically the binary payload, which identifies the unique ID for that particular credential being stored on the device. We also have the attestation response back from the service. In this case, the service is actually the local client. It contains the actual authenticated attestation statement data in the attestation objects field. And also client data JSON contains a JSON representation of what the browser was asked to create that credential. In this case, the options object that we specified in the previous slide is going to be contained in that payload. And we can also specify the type of public key we want, which by default is public key. So now let's look at the authentication workflow. Very similar sort of thing. In this case, we want a client to actually authenticate against a relying party. The server then provides a challenge to the client, essentially saying, okay, based on the credentials that I have for your account, can you actually satisfy this challenge with your private key? The client then provides a signature back to the server, which then can validate the signature using the public key. And if it's successful, it will actually authenticate the user and permit that credential being used. Having a look at this, very similar sort of options. In this case, we have a challenge that's provided from the actual server itself. In this case, we just specify there's a challenge from server sort of variable somewhere. We then specify the allow credentials. You don't necessarily need to do this, but this is highlighting that you can actually specify certain properties you might not want to use in particular applications. We do have to have the ID specified as a mandatory thing. So we want to actually state that we want a particular credential to be used. In this case, the server has registered, for example, a fingerprint. Based on the client, is requesting that specific fingerprint to be used. We also can specify the transport mediums. In this case, you don't necessarily need to do this. By default, it will use any potential transport medium available. But if you do want to lock down your server using particular types of authenticators, for example, USB security keys, you could easily specify just USB transport is the only allowed method. We can also configure the timeout here as well. Once we've got that, we can then try to request credentials and see if we get a hit. If we do, we get everything that we need back, including the signature that we need to provide back to the server, and also any additional information, for example, like if we have a user handle associated with that credential. This can be used by the server to perform additional validation if the credential is valid or not. Now let's look at a few design considerations with using WebAuthn. One of the key sort of things that you might have realized is that the cross-platform authenticators are different enough that users might get confused. Users might not be aware that if they use a fingerprint on the phone and on a laptop, that their fingerprint would actually be considered as two separate different credentials. Most users will likely try to use these because it's the most available sort of authenticator method that would be available on their platforms that they use on a day-to-day basis. As a result, we really need to be considerate of the UX impacts, since users might actually get confused why they need to register their fingerprint multiple times across multiple different devices. So applications and the customer experience workflow should really consider how this is highlighted to the user. For example, using diagrams or some sort of workflow to help them understand how the actual credential is being used. Which also brings another point. What happens if the user loses their authorizer, and more likely when they lose their authorizer? In this case, you might want to enforce a policy where if you're using multiple passwordless authorizers for an account, that you actually enforce that more than one is used at any given time. This way it reduces any risk of an account being lost or a user is calling up the help desk for an organization trying to recover their account for whatever reason they've lost their authorizer they used. This also highlights that you need to have a really well-established account recovery process when users lose authenticators. Even if you look at a typical bank scenario where they might be using SMS for a two-factor auth sort of approach, you need to have some sort of fallback mechanism depending on the product, but most services will need to have that sort of fallback process. If you've got more of an anonymized service, you might just tell the user, sorry, you need to make out another account because there's no way you're going to be able to recover that. So if you're interested in implementing passwordless authentication, there's a few ways we can look at how we can actually implement this in a workflow. For developers, there's quite a lot of strong documentation support within the web community for actually implementing passwordless authentication using the WebAuthn API. In 2019, a lot of the major browser manufacturers actually worked together to release this API at the same time to sort of encourage a lot of users to use this platform for building more secure experiences. Auth0 provided a really fantastic overview and debugger for WebAuthn at webauthn.me. It's a great sort of resource to look through the tutorials, but also the debugger to see how the actual WebAuthn API can be used and manipulated to work for your use cases. Additionally, there's a really great resource on GitHub called Awesome WebAuthn, which is essentially a collation of resources related to WebAuthn, which, for example, is articles, slides, and other presentations. For organizations, if you're using a particular identity provider for your single sign-on requirements, there's a good chance that your identity provider will actually already support this standard. Many providers are already starting to support WebAuthn or very close to supporting it. In most cases, they've been using it for multi-factor authentication mechanisms. In some cases, you can actually create a custom experience using just a passwordless experience if you deem that necessary. Definitely the easiest way to actually use passwordless authentication in an organization, simply because you can actually enforce that users can use this quickly on a single sign-on environment for a lot of different types of corporate applications. If we look at web browser support, even though the standard was introduced early last year, there is a lot more browser support lately as of right now. So all the major web browsers support it. That includes Microsoft Edge, which is essentially Chromium these days, Firefox, Chrome, Safari, Opera, iOS Safari, but also Android browser and the Chrome engine for Android as well. So most of the browsers essentially are covered. Using Can I Use as a resource in terms of statistics, that covers about 85% of users on a given basis. Having said that, if there's some mobile platforms that they can't use, for example, might be using Samsung Internet or something, they could easily use a different device to try and access a particular platform. In this case, this is where progressive enhancement, that concept, comes really into play. You might want to still support legacy devices, and if they don't have support for the WebAuthn API, you just might not expose that functionality or provide some sort of alternative way of authenticating in, for example, potentially an SMS approach. So to conclude, let's look over what we just sort of discovered today. We found out that password authentication can actually be implemented today without too much hassle. Browser support is very strong on both desktop and mobile platforms, and many identity providers are already starting to support the standard as of today. We can create a much more improved user experience simply because users don't have to worry about memorizing secrets, and can also be used as a standalone process or also complement an existing user password authentication mechanism. This definitely will help increase the security of user accounts simply because it's creating a lot of different options for multi-factor authentication. Most applications tend to only support SMS, whereas this is a nice free sort of way of providing multiple different modalities for authorizers, and users can pick whichever modality is most relevant. The account recovery also needs to be, the strategy needs to be really well implemented in the application. Developers need to consider workflows of when users lose authenticators, simply because this will potentially happen, and most likely will happen on an often basis when you've got a lot of users. So if you don't have this really well mapped out, you're likely going to get a lot of calls to your help desk. Thank you for watching this presentation. If you still have any questions for this presentation, please head on to our Slack channel and post any queries that you might have, or also just join in any of the community discussions. But thank you, and we'll be making this available online as well, so that way if you do want to reference this again, you're more than welcome to.